Hi folks, and welcome to Open Analysis Live. So today we're going to be doing something a little bit different, actually really different from the normal videos that we put up here. For those of you who have been with our channel for a while, you know that we have a policy of only reverse engineering malware. And today we're actually going to be looking at a non-malicious application that was released to help people track COVID infections. So I live in Canada. And this has been put out by the government. There's also one that's been released in the United States recently, and Australia and many other countries are also releasing similar apps. Now what we're going to do today is I'm going to show you how to actually reverse engineer this application and prove that it is both safe to use and that it respects your privacy. There's no privacy implications whatsoever to using the application. And instead of just telling you guys this, I'm going to actually give you the tools to verify this yourself. I'm using it right now. On my phone, I think it's safe to use, but again, don't take my word for it. Stick around for the video and I'll show you how you can assure yourself that it's safe to use. Now, this is a bit of a sensitive topic, I think. I will probably be demonetized into a black hole, but I thought it was really important to put out because I think the more people that use this application, the better it works. And I think I've seen some numbers saying that at least 60% of the population needs to be using it for it to be effective. And I think the more people that are confident using this, knowing that it's safe, the more widely adopted it's going to be. So I have a bit of a preamble explaining what goes into this app. If you just want to learn how to reverse engineer an Android application, I'll put a timestamp here in the video and you can skip ahead there just to get to the technical part. So with that, let's get into it. Now, the cool thing about this whole project is that there's been a real emphasis on transparency. So what I'm going to do is I'm going to go through some of the documentation first of how this works. The architecture is all available online and they have a lot of good documentation addressing the privacy concerns and how they built the system to address those. And then the actual app itself, the base platform or the skeleton of the app, was developed by a group of people from Shopify, a Canadian company actually, built an open source version of this application, which is now being used by the government. They rebranded it, put in their own configuration, and then built the app and deployed it. So not only can we look at the protocol that was developed by Apple and Google, but we can also look at the source code of the application itself, which is pretty awesome. It's very transparent, and they did this on purpose in order to assure people that there's no privacy concerns here. So we can start there, and once we have an understanding of how this all fits together, we'll go and take a look at the actual application by showing you that you can decompile the app and basically match it back and see that nothing's been added to it. So that's how we're going to lay this out. And for those of you who just want malware, don't worry, we'll be back in a week or so with some more malware analysis videos. So basically the way this works, if we scroll down to their documentation here, it's actually quite well documented. You have your phone and every 10 to 20 minutes it is generating a new hash basically, and that hash is called your key. Oh, hold on. I'm editing this and I realized that I referred to these as keys. Really, they're called IDs in the documentation. It doesn't really make much difference, but you'll hear me refer to them as keys throughout the rest of the video. For some reason that got stuck in my head and I just thought keys as I was describing it. Okay, back to the video. And every time you come in close proximity with another phone that has the application running, you guys exchange those keys. And the phone just keeps a list of the keys that it's seen locally. They're actually stored in a zip file, which I'll show you guys later. So your phone is moving around and the Bluetooth is basically beaconing out, looking for other phones. And when it finds another phone, they exchange keys. So the important part about this protocol is that it's not doing any sort of geographic location and it's not doing any sort of identification of who you are. All it knows is that it has a list of keys of phones that it's seen recently, and these are stored locally to the phone. So basically there's no information being passed up to a server or anything like that. Now, if you are unfortunately diagnosed with COVID, you'll receive a one-time use key from the government, and you'll actually have to add that key into your phone. So there's nothing automatic about this, and it's your choice. Now, the hope is that people who have been diagnosed with COVID will see the benefit in reporting this through the phone. So what you would do is you would enter that key into your phone, and that will submit to the government server a list of all of the hashes that you have used for the past, I think it's 14 days. So these are the hashes that your phone generated every 10 or 20 minutes. And so you'll send those up to the server. And of course, those hashes don't identify you. They don't identify your geographic location or anything like that. They're simply just a random hash. Then the government server will take that list of hashes and it will distribute it to every COVID application that calls into it. So at the same time that you're exchanging beacons, you're also polling that server, asking for a list of infected keys. So the server will then send down a list of known COVID hashes. And of course, your phone is storing all the hashes of the phones that it's come in contact with. So it just checks those infected hashes against the hashes that it's seen. And if one of them matches, then it knows that at some point you were in contact, you were in proximity with someone who's been diagnosed with COVID, and it will alert you. So that's the underlying architecture of this. So you can see that based on the system, there's no way that anybody could know who you are, where you've been. There's basically no information about this. So that's the underlying protocol. Now, there is basically this exposure notification specification for how the Bluetooth stuff is set up. It's kind of in the weeds, and if you're interested in that sort of stuff, you can go look at it. But what we're going to focus on today is the higher level implementation. So this is the protocol that is basically a module that you can call from your application. And what we're going to be looking at today is how that's actually set up in the application. So this is the exposure notification API documentation. So this is how to interact with that subsystem from your application. And so this was basically used to develop this open source application, which is here on GitHub. There's a server component and a mobile component, one built for Android, one built for iOS. And this is basically what the application is based on, the one that you would download from the Play Store or from the App Store. So if we look at the mobile version here, this is what's been developed by the volunteers from Shopify. And basically the way that they've architected this is sort of interesting. They have a base set of code, which is doing the underlying interaction with the exposure notification API, and it's also doing some of the network communication. Then on top of that, they have a device agnostic React component, and that's the top level component of the app that displays notifications to you and stuff like that. So there's basically two different code bases. So there's the stuff that would be underlying here. So this is basically for Android. The higher level stuff, the graphics and all that, are written in React. TypeScript TS is the extension here. And all of this is cross-platform basically. So they didn't want to rewrite that code specific for Android and iOS. And so it's just high level TypeScript in React. Now, when we get to reverse engineering the app, this matters because the low level stuff is actually we're going to be looking at the Android version, by the way. So for Android, the base level stuff that's actually interacting with the API is compiled into Dex, and this is basically it's not native code because those are .so, but it's basically like the app code for Android. Now that's easy to decompile, and I'm going to show you how to decompile that so you can go back to the source and read it. The React component, however, is a little bit different. So normally when you deploy a React component, the React part for your app would be basically minified into a file that you could then, inflate back to JavaScript. However, this application uses the Hermes compiler for JavaScript, and what that means is that the JavaScript gets compiled down into a bytecode version, and I wasn't able to find a tool which could decompile it. I know that it can be reversed, and I just didn't have time to build something for it, and I wasn't able to find a tool to do that. So when we get into reverse engineering, I'll show you that top level component is not fully reversed in this tutorial. It can be if somebody takes the time to actually build that reverse engineering tool to bring the Hermes bytecode back to JavaScript. Now, that's not going to slow us down in proving that this application is respecting your privacy, because we can still see the interaction with the API through the compiled Dex code, and I'll show you that. And so we can still verify the application. The only thing that they're really doing in the React component is they're doing the notifications to the user, so like what you see in the actual app, and they're doing some uploading of the one-time exposure key to the server. Again, there's no interaction with your GPS or Bluetooth or anything like that from that part of the component, so it's the lower risk, I guess. in terms of privacy and security. So let's pop over to the source code here. Okay, so I've just downloaded the open source app. This is the GitHub tree that we're just looking at. And I'll just take you through some of the important parts of the application. So this kind of reminds me, sometimes reverse engineering is really just about reading documentation. And I definitely think that in this case, it kind of reminds me of that. Because a lot of this, because they open source the app, a lot of it is very easy for us to do. All we need to do is just check out the code, make sure that we are okay with the decisions made in the code, and then we just double check it when we reverse engineer the application. So it's actually pretty straightforward. For those of you who aren't familiar with developing for Android, the syntax that you write the application in is Java syntax, but these KT extensions indicate that it's Kotlin, which is like an extended version of the Java language. I might be getting that a little bit wrong. I'm not an Android developer. So basically that's why you have the KT extension here. Okay, so now let's take a look at the COVID API implementation in this application. So we have the COVID Shield section here with all of the code related to it. And I think probably what we'll do is we'll look at the modules here. So let's look at the COVID Shield module first. This is basically like the general implementation for how to interact with the exposure notification API. So the first thing I want to mention is you see these React methods. So that declaration is a way to expose this Java function to the React application. So remember I said the React application is doing all the UI stuff, it's sitting on top, and basically these decorators mean that React application can call this Java code here. So this one is download diagnosis key file. Obviously that is, it's pretty self-explanatory. That's going to be where they call to the server and they pull down a list of temporary keys that have been identified as COVID infected. So they basically have that function or method here. There's a write file method, and here's where I was saying you can see that they store the keys in a zip file, but it makes sense. I guess, these are just files of hashes that they're sending around, so, they don't need anything fancy for this. So basically, those are the two methods that are exposed by the COVID Shield module. The exposure notification module has some more methods here that are important. So there's like the stop, so that if you just want to stop the app from sending beacons, reset data, etc. Detect exposure is where it basically takes the list of stored keys that the application has seen and it compares them against a list of known COVID keys downloaded from the server. So this is basically how you determine whether you've been in contact with someone who has reported as having COVID. So the important stuff here is that this is all verifiable. I mean, if you can read Java, it's a very self-explanatory language, so it's kind of easy to read. So you can go through here and verify each individual component, make sure that it's working in a way that you feel safe using it. And again, my opinion, looking through this, there's nothing here that seems even remotely dangerous. All of it is pretty much doing just the exact thing that they say they're doing in the architecture. Basically, these functions just download a list of infected keys, compare them, store the keys that it's received from other devices, and allows you to self-report with a one-time use key from a health service provider. So again, this is open source. I'll link the source to it in the description of the video. So the next part to this is we want to actually grab the Android app from the App Store and decompile it and make sure that the code in that app is the same as the code here. So this is very different from what we'd normally be doing when we're doing malware analysis, where we don't have the source code. This type of reverse engineering is usually called like an assurance audit. That's the sort of general branch that this would be under. So basically what you're doing here is you're verifying that the compiled app is basically represented in the source code. So there's a match between them. And that's sort of the final step here. Once I show you guys how to do that, you'll have all the tools you need to verify for yourself that this app is safe to use. Here, an Android application, you're going to need basically four things. You need the application, you're going to need a dex to jar decompiler, so that decompiles the dex files and compile the application back into Java so you can read it. You're going to need some sort of XML converter for the binary XML manifest file, which I'll show you guys in a second. And you're going to need a Jd-gui or some other jar to Java decompiler so that you can actually decompile the Java further into code that you can read. There's also a tool, APKtool, which bundles a lot of these features into it. I'm going to link a list to all the tools down in the description of the video. They're all free and open source, so you can grab them and use them as you see fit. So first step, getting the application. You can see here the app is in the Android store. This is the ID for it here. Now, I don't want to break any Google terms of service or anything like that and show you how to get this directly from the Play Store. I'll save that for those of you who want to Google how to do that. You can find information on that, just not in this video. What I will do is I will show you there's another way to get Android applications. There's this amazing platform called Koodous, which is built actually to track malicious applications. It's sort of like the VirusTotal for Android. If you guys are familiar with VirusTotal, probably most of you are. So basically, these guys allow you to download Android applications, and they have a massive collection of them. In fact, I really like the project. I've been a huge supporter of them over the years, so go check that out. That's one way to get the application, but if you want to be 100% sure that the application you're getting is the one from the Play Store, again, you can research yourself how to do that, but I don't want to break any terms of service here on the video. So we have the application sitting here in our directory. It's an APK file. Now, for those of you who are familiar with Android applications, it's going to be a little bit boring to start out with, but we have to get everyone up to speed. So basically, APK is just a zip file with a renamed .apk. So if we rename it to .zip, we can unzip it. There we go. So it's just a zip file. Now, if we cd into the directory, okay, so it's unzipped here, and now we have the contents of the application. So the first thing we want to look at is this Android manifest. So that's this file right here, Android manifest.xml. If I was to try and just look at it directly, you can see that it's actually binary, but not a big deal. There's a tool that you can use to convert this back into XML so you can read it. Yeah, so we have this Java tool, again, I'll link in the video description, AXML printer, which basically just prints out the XML from this compiled XML file format. So we can use that like java-jar AXML and then Android XML, and then we'll print it out into a text file. Okay, and then we can VI the text file here. And we can see now it's back to XML. So why is this file important? Well, this is actually what dictates the permissions of the application and the receivers, etc., that can be used by the application. So whenever you load an application, this is when you get that permissions pop up saying, like, do you want to allow this app to do X, Y, and Z? That's where these are listed right here. So you can see the permissions for the application are actually incredibly limited. It's fantastic. All it needs access to is Bluetooth, not even Bluetooth location. So only Bluetooth because they're only sending beacons, they're not doing any sort of location. And it needs internet access in order to upload and download the key files from the server. So that's basically it. It has some other stuff like the background service so it can run in the background. But that's it. These are all the permissions that it uses right here. So again, you can verify that. Now, this XML is also used to, like I said, pop up that notification. So of course you don't have to look at the XML, you can just see the pop-up when you install the application on your Android device. These are basically listed as the permissions. So that's the first step here, is just to see what permissions it has. Again, these match up with the open source application, so all good there. The other thing that this has is it has like the broadcast receivers. So these are basically like the callbacks in order to get information from the exposure API that's running in the background. So these are like things where if you've come in contact with a hash that's been identified as COVID, this is like where the notifications will come from. So you can go through these and verify that they're all the same ones that they have in the open source application. I already did that before the video. There's hardly anything in here, and again, everything totally makes sense. There's nothing weird in here at all. So we can get rid of that. First step done, check the permissions, check the receivers, everything seems good there. The next step is to actually look at the code. So if we look at the tree here, there's two classes.dex file. This is where the compiled application code is. There's also, like I said before, there's a React component here. So under assets, there is a something called index Android bundle. And that's the compiled JavaScript for React. So if we were to take a look at this assets index you could see it's binary because it's compiled, but there are some strings in it. If we can actually do a strings on it, assets, index, Android. So you can see that they're basically like compressed strings from the JavaScript stuff. So these are things like, for example, the libraries that they're using, some of the strings from that. And I think in here as well, if we look for HTTPS, you can see basically these are information websites that are in the application. So if you do come in contact with COVID, some of these URLs will be presented to you, so you can get more information about how to react to this potential exposure. So you'll see those URLs in here. Now, like I said before, I couldn't find a tool to decompile the Hermes compiled bytecode back into JavaScript, but like we saw in the application source, any of those bridges where they're talking to the actual application are going to exist in the compiled DEX code. So we don't have too much to worry about from this, even though it would be nice to reverse engineer it and take a look at it. Any of you guys watching this video, if you want to write a decompiler for the compiled Hermes stuff, that would be amazing. That would be really cool. But for right now, we can't do that. But again, the risk is very minimal because the interaction with the exposure API happens in the DEX code. So that's the next thing to do, is take a look at that DEX code. Now, in order to look at it, what we want to do is we want to convert the DEX back into a jar. And so there's a tool called D2J dex to jar. And this basically converts those DEX files into a jar file, and then we can use something like Jd-gui to convert the jar back into Java code, and we can read it. So again, this is open source, and I will link it in the description of the video below. So let's look at the classes DEX. There are probably going to be a couple issues with the decompiling. There usually is. Stuff that it doesn't handle. Yeah, so you get a little error issue here, but it's not a big deal. As you'll see, almost all of it is decompiled. These are just a few extra things that didn't get decompiled, so not a big deal. So now we can use something like Jd-gui to take a look at the jar file. Okay, so we've opened up that jar file that we just created, and so now we can see the app COVID field modules all in here. There's the config file. So this is where the servers are configured, where you're going to actually call out to the HMAC, which is used when you're retrieving the key files from the server. Basically, all of that is configured in this configuration file here. And what we want to do is we want to go through these decompiled classes and make sure that their code matches up with the open source code. Now, something that I should point out here, you're going to see these like metadata tags with a bunch of interesting metadata in them. This is actually an artifact from, I believe, the fact that this is not Java code, it's this Kotlin, which is like this, augmented Java. So they have the metadata from those classes are printed out here in a string that you can read. And this is actually kind of helpful. You can just see some of the context around what's being passed into it. But again, you can also see that if you read through the Java code here. So the first thing we want to do is we want to just make sure that things like this look correct. So download diagnosis key file. So remember, we saw it in our application here, code shield module diagnosis key file. So we just want to make sure that it looks the same, and we can see here that it certainly does. Now, the one thing is you're going to see a lot of this sort of extra inheritance or instantiation type stuff in the decompiled Java. This is simply an artifact of the fact that it was compiled, so it's a little bit messier to read. But basically, it's the same code. And the other thing that we might want to look at is the exposure key class. So this is where they actually generate your keys. And so we want to look at what information they store in there and just verify that it's actually the same stuff in the open source application. So they have like the key data, rolling period, interval number, blah, blah, transition risk level. All of that is, again, just defined in the spec and in the app here. So we can see that there's nothing added here. So now this is just a shallow dive to show you how to do it. I actually took a more thorough look through the code because I was curious for myself, and I wanted to make sure that when I told my friend that it was okay to use, that it definitely was okay to use. So I took a closer look through here, which would just be kind of boring for the video, but I didn't see anything strange in here. It looks like it's basically just the open source application with a few additional information links that are specific to your province. So it's just kind of a reskinning of the application, which is what you would expect. So don't take my word for it. Don't listen to random people on YouTube. Use the tools that I've showed you here today, and you can go and verify for yourself. And once you're assured that it's a safe application to use, install it, keep us safe, and, let's all do our part.
I'm doing my part.
I'm doing my part.
I'm doing my part.
I'm doing my part too.
So I know this is a little bit different from what we normally do, but I thought it was important to do, and hopefully this helps a few of you who are unsure about using it. Hopefully this gives you the tools that you need to basically assure yourselves that it's a safe application to use. With that, we will be back in a week or two with a malware analysis video. We have something pretty good for you guys in store, so stay tuned for that. And until next time, keep exposing the mechanics behind the malware, and stay safe, guys.
Yeah, you know you fucking feel me. Yeah, you know you fucking feel me. Yeah, you know you fucking feel me, right?